data structures using C. In this lecture, we will deal with the implementation of binary tree. You already we have given introduction to binary tree, how to create this binary tree, etc. theoretically, and figuratively we have done. Now let us get into the implementation of this binary tree using C programming. So we will learn how to implement the binary tree using C, and implementation various traversals we have already done: in order, post order, and pre-order traversals. We know, suppose binary tree is given, how to traverse it using these methods. We will implement these during this session. So first thing is, how do you represent the node of a binary tree? As you know, every node has a data item. This is just a simple data item would be a number. And then it needs to be connected to two more subtrees or two more leaves. So how do we do that? So that is the first question. So we create a new data type using structure to represent the node of a binary search tree. So this is, for pictorially we represent it as like this: number, then right link and the left link. So this is pictorial representation, and here this way we make a new data type called the tree node, which contains the data item number and links to right and left. So I say type def struct tree type, this is the tag I'm giving. Then it says structure tree type star right, pointer to the right and pointer to the left. These are the links to the left and the right subtrees. So with this, what the next thing is, we have, so then of course we create a tree node called star T. T is the will be the head of the, or the root of the tree. So now the first thing is always, as we have done in the case of linked list and in the case of queue, first thing is we write a function program to create a node. This time it is a node of a tree. So therefore tree node, make tree node. Earlier we said make list node and make queue node. Now we are going to say make tree node. All the rest is almost the same. So I pass a number which is going to be the data item of this node, and it is going to return a pointer of the type tree node, it is going to return that. So therefore first I declare a pointer new node, I allocate memory to this new node, then I assign this number to new node number, and new node right and left are assigned null, they are pointing to null. And then we say at the end, return new node. So this is what is first function. Then you see, for example, here make tree node out of 20, and this node will contain the address of this node, which contains data item 20, and right and left pointing to null. This is the pictorial representation of the same node, which contains 20, and left is null and the right is null. These links are null, pointing to nothing. So with that we come to now inserting. We know how to create a tree node. Now we want to insert this tree node and create a binary search tree. So there are cases now. Case 1 is root of the BST is null. That is, means there doesn't exist a tree. I have declared a root and it is pointing to null. So then what do I do? Make the incoming node as the root of the binary search tree. So I've created my first node, and that is going to be the root of the binary search tree. So for example, I use this function which I've written earlier, make tree node out of 60 node. Then what happens? If root is equal to null, that means there is no tree, then I assign this node to root. This address node contains the address of this node containing 60. So I'm assigning that address to root, and therefore this becomes the root of my tree, binary search tree, and I say return. So here, for example, I've created this node containing 60, and then that is the node root of this node, and then the left will point later to left subtree, and right will point to later the right subtree, depending on the values on the nodes, incoming nodes. With that, we come to case 2. Now there is a tree existing. Maybe it contains one node or 10 nodes, uh, but there is one existing. So how am I going to insert the incoming node into this tree is the question. Again, first I traverse the tree to find the proper location to insert the incoming node. I have to traverse. I have to go either in the left direction or the right direction, depending on the value of the incoming node. So we will deal with that. So therefore, this is for traveling. As this is a pseudocode, as long as the current node is not, the value at the current node is not null, or no, the current node is not null. What do I do? If number is incoming number is less than current number, then I traverse the left subtree. So therefore, previous is equal to current, current is equal to current, right? So if the number is greater than current number, uh, then what do I do is I traverse the right side or right subtree. Previous equal to current, current equal to current, right? So this is how I traverse the tree, starting with the root, Then what? So I come to a place where previous the current points to null, therefore previous node is there. So I attach the incoming node to proper, either to the right or left, depending on the value of my number or the value of the number data item on the new node. So then what do I do? If number is less than previous number, because here, as long as current is not null, so automatically when you come out of this, current is null but previous has value. So then I have to find out if the number is less than previous number, so that means it has to go on to the left. So previous left is equal to node, otherwise I say previous right equal to node. So I assign this node either to the left or right, depending on the value of the number on the node. The number here, you can say node number is less than previous number. So these are the two things. I traverse the tree either on the left subtree or the right subtree, and once I know the appropriate location, I attach the incoming node to the previous node. So this is, I'll show you pictorially now. So inserting a number. For example, I have number called 25. So how do I do? So I come here, always we start with the root node. As you see, number is less than 50. Therefore, I start traversing the left. So here, therefore, current number is not equal to null. If number is less than current number is less than current, now this is pointing to head is pointing to current, therefore current is less number, so this becomes previous, this becomes current, this becomes previous, this becomes current. Now again, here I have come here, I have to again ask this question, is number less than 20? No, it is here again, the number is not less than, therefore previous, this becomes previous, current is current right, so I am here now, current right. So again the same question, is the number less than 30? No, yes, it is less than 30, therefore this becomes previous, and therefore as you see, the previous current has become null, current is pointing to null, therefore what do I do? So therefore if the number, here I am here, if the number is less than previous number is 30, incoming number is 25, what do I do? Previous left is equal to node, I am attaching that node here to the previous, previous left, correct. If number is less than previous number, previous left is equal to node, because always less number will be on the left hand side. This is how we have attached 20. We'll take one more example. Yeah. So for example, if the incoming number is 90, then again I come here, I ask the same question, is number greater than current number? Yes. Then I move, as you see, if it is yes, therefore previous, this becomes previous, this becomes current, because current right. So this is, then again I ask the same question, is number greater than uh, and 80. Yes, it is so. Therefore, what do I do? So immediately I have come this current right is pointing to null, right is pointing to null, therefore 90, as I am here, current is null, previous equal to 80. So I ask this question, if number is less, it is not, it is greater than number, therefore previous right is equal to node, so I'm attaching the node here. So this is how we go on doing that. Very simple. It is done systematically, comparing every time the incoming number with the number on each of these nodes. Either you move on to the left and left here, or it is right and right here in this case. So this is how we are going to insert the incoming node onto the BST binary search tree. Now here is the whole uh, code for that. So it's insert tree node number. Now we have declared root as the global, that is a global variable. If we don't declare it as a global variable, I have to give it here. To make it easy, we have declared it as global variable. So naturally, therefore, we come here and we have declared three variables: new node, current, previous. And I create the new node, make tree node out of this number, and I'm assigning root to current. And the first case one here, if root is equal to null, root is equal to new node return. That is what we have done already. If it is not null, there is already a tree. Then case 2, traverse the tree to find the right position. Here I am traversing the tree. I have explained just now. As long as there is current, while current, you do that. You do that, and then you come to a place when current is equal to null, previous is equal to contains the pointer. Therefore, you ask the question, if number is less than previous number, it is less. Therefore, I attach to the left hand side. If it is more, I attach to the right hand side. So that is what we are going to do. This is insert tree node. And now we come to, now we have understood how to insert a given node to a binary search tree. Only two cases. First case is the number, the tree does not exist, or the root is equal to null. Therefore, make the incoming node the root of this tree. Otherwise, you traverse the tree till you current becomes null, and you attach the incoming node either to the right hand side or the left hand side of the previous node. That is so simple as that. Now we come to what is called the traversals. We have already done this: in order, post order, and pre-order traversal. And you know, in the case of in order traversals is left, root, right. Same thing we follow. Now we are going to write functions for that, and these are recursive functions, much easier. Recursive functions we are going to write. So we say traverse the left tree, subtree, left, then process the root node R, root node. That means print. So your traversing means you're printing. So you print the content of that node, root node, and then you start traversing the subtree in the in order. So this is in order. So left to root, you have to just remember left to root, right. So when root is there, you print the content of the root. Otherwise, you go on searching the left. So in this case, post order is left to right root. So you traverse the left subtree, traverse the right subtree, then you come to the root node and then print the content of the root node. Similarly, pre-order traversal, you start with the root, therefore root left right. You start with the first root and you print the content, then you move to the left, and then left, and then go on printing every time, and then you get your left subtree and the right subtree of the tree. So these are the three ways in which you traverse the uh, binary search tree. Now let us go into writing of the functions. Very simple. So in order, void, in order, tree node root. So I say left root right. This is in order. Therefore, you say if as long as there is root, what do you do? In order, then you traverse the left, as you say left, traverse the left. When you then you come to root, you print the content of the root, then you traverse the left. So this is simple thing. So this is therefore as long as there is root, you at the end you will get null, and the moment you get null, you print the content of the root numbers. That is what you are going to do. And This is similarly here again same. So if just left right root, therefore first you traverse the left subtree, then you traverse the right subtree, and then you print the number at the root. And here in the case of pre-order root left right, you print the number at the root. The in order root left, you traverse the left tree, and then you traverse the right tree. Automatically it will give you the content of the tree. So with that I show you the outcome of this. As you see here, so here I've entered these numbers, then I've say in order traversal. As you see, this tree has in order traversal, as you know, gives you the numbers in the ascending order. So 20, 50, 60, 70, etc. Whereas in the case of this is what? Pre-order traversal. Pre-order traversal, as you know, it gives you root, then left, left, etc. So you've got root here, left, then 20. 20 is the lowermost, as you see here, 20 leaf. And then you have got 60, 80, 75, 90. So this is the pre-order traversal. So as you see, this is the root 70, then it goes to 50, then it goes to 20, and then it comes back again, then it's print 60, etc. So then we come to here what is called the post-order traversal. Post-order traversal. Post-order traversal. So post-order traversal is left, right, root. That is the thing. So it prints 20, 60, etc. It's very easy to understand in order traversal. Naturally, the numbers are arranged in the ascending order, the in order traversal of a binary search tree. So these are the three traversals I'm showing you. Again, this is the complete program now. Complete program now we should be familiar with. As you see here, we are creating a new data type called tree node, and there's a tree node root. This is going to be the root of my tree. All these are function subprograms we need. We have just at the moment we have done only make tree node, insert tree node, recursive I have given. We'll go through that recursive function, but we have used only insert tree node, then in order, post order, and pre-order. Then print tree, we have done already that function earlier, print tree. Then we'll come to in the next lecture, we are going to do the binary search this thing, a given number in the tree, the recursive function to do that. Then we will also get into delete node. We have done that already, but we are going to implement that in the next lecture. This is the menu function which we need because we are writing a menu driven program, and this is also init tree. We need that init tree to initialize the tree, that means make the root null. And of course this is we needed in deleting, predecessor is needed in deleting the node. We will come to that in the next lecture. So this is the main program, and as you see, we initialize the tree, and here then you have got as you see here, we have number and choice. So we initialize the tree, then we get into this while loop. As long as there is choice, I have put it as 1 there, then the menu is displayed, and switch statement. Case 1 is enter the number into, so go on entering the numbers one after the other into the your tree. So I am using insert tree node normal. You can take that normal. So then case 2 in order, case 3 post order, case 4 is pre-order, then case 5 is exit, otherwise default is menu. So this is the main program. Just this much is the main program, menu driven program giving. So I come to the recursive function to insert a new node into the binary search tree. I have shown you a algorithmic method how to insert. There is also a recursive, that's why I've declared it as insert tree node recursive. Very simple. When it is recursive, I have to say tree node star root, and also it has to return tree node and int number. In the case of the other one, I say just int number. So insert tree node number I say, but here we need to give this tree node because it has to, every time it has to return the root of the subtree, main tree, subtree, etc. So simple here. First thing is the argument is the same. If the root is equal to null, you make that new node and assign that new node to root. Otherwise, what do you do? If the number is less than root number, you insert tree node recursively at the left side. Otherwise, you insert the node onto the right side, right subtree. So this is how it goes on and on. Recursively, it goes on and on. It comes to null. That particular node is going to be null, and automatically it is going to insert either onto the left or onto the right, depending on where it has to be, depending on the value of this number which is checked here. Number is less, you go to left side. If number is greater than root number, go to the right hand side. So this is a recursive function to do the same thing, much less steps, but the other one explains to you exactly where and how you are inserting the given node into the binary search tree. Thank you.